Good morning, students, or good afternoon, depending on when you're watching this. This is my second decimals introduction video, and I want to go over some other things about decimals that you need to know and reinforce some previous concepts. But take a look here. Decimals are based on tenths, hundredths, thousandths, etc. Now, each of these has a th at the end because they are all equivalent to fractions, right? Decimals are a different way to express part of a whole. Every single decimal has a fraction equivalent. So what does all of this mean? Well, over here on the side, I have some base 10 blocks that I want you to take a look at, and I am going to highlight them in, right? So if I highlight them, there's 1/10, here's 2/10, here is 3/10, here is 4/10, here is 5/10, here is 6/10, 7/10, 8/10, 9/10, 10/10. Now, what does that mean? That means I have highlighted one entire square. So, as you may know from fractions, 10 over 10 equals one whole. So this square is one whole square. It is also equivalent to 10/10. Each column is a tenth, right? You might also notice it's split into little tiny squares, and if you multiply 10 by 10, you'll find out there's 100 little tiny squares in here, and each of those is 1/100th, and I've highlighted all 100 of them, so it's 100 over 100, which is, again, equivalent to one whole. So let's take a look here and let's write that number down. So this is going to be one whole, right? Which is 10 over 10 or 100 over 100. Now the next thing to look at is right over here. Now I have a second tenth right here, or I'm sorry, not a second tenth. I have another tenth right there. And then I have a hundredth right here. I've now shaded in all of it. So let's figure out what this means. So I have one whole square shaded in here. And then you'll notice it takes 10 of those to go across. So this column is a tenth. So it is equivalent to 1/10 of a square, right? And then this little tiny dot, or cube, I should say, is 1/100th. There's 100 of them to make the whole square, so that is 1/100th. Now that's how we could think about it as fractions, right? But if I wanted to put all of that together, I would have to use equivalent fractions, right? Remember, I can't add my denominators. I can't add 10 to 100 onto the denominators. You don't add your denominators ever. So if you use equivalent fractions, you would get 10/100ths, because here's 100th, 200th, 300th, 400th, 500th, 600ths, 700ths, 800ths, 900ths, 10/100ths, 11/100ths. So 1/10 equals 10/100ths plus one more, 11/100ths. So this whole thing equals 1 and 11 over 100, right? Okay, so this is adding all of these different things up. So this whole thing I've shaded in is 1 and 11/100ths. But now let's look at it with decimals. So I still have one entire square filled up, so that's 1. And now I have 1/10, but as a decimal, I'm going to write 0.1. And I have 100th, so as a decimal, I'm going to write 0.01, because this is the 100th column, the 10th column, the ones column, right? Here's a 1 whole, here's 1/10, 1/100th. So when you put them all together, you get 1.11, and that means 1 whole plus 1/10 plus 1/100th, or 1 and 11/100ths. All right, so those are some basics. Let's go to a more complicated problem. Take a look over here. I have 0.34. 0.34, and I'm going to compare it greater than, less than, or equal to 0.6. So in order to do that, let's do some shading. 0.34, I have 3/10ths and 4/100ths. So if I'm going to shade in a tenth, I'm going to shade in a column. There's one of them, and I'm not shading super well here, but you understand what I mean. Here's 2, and here is my 3/10, right? So this right here is 3 over 10, right? Now I have 4/100ths. Each one is a hundredth. So 1, 2, 3, 4 more hundredths, right? And that's what it looks like when you shade that in. Okay, so this is 4 100ths. Okay, now, since we're comparing greater than, less than, or equal to, it's a very common mistake for students to say, oh, look at this number has more digits, so it must be bigger than this number over here, right? But that's actually not true. It actually is not bigger, because watch what happens when we shade it in over here. Here I have this number, which is 6 tenths. Okay, so 6 tenths, I have to shade in 6 columns. There's 1, there's 2, there's 3, here's 4, here's 5, and here is 6 tenths. Now, if you take a look, that is definitely more shaded in than over here. So let's talk about equivalent fractions and what does this mean? Okay, now if you'll take a look at our 3 tenths, which is right here, you will actually find out that that is equivalent to 30 of the small ones. So that is 30 hundredths, right? Equivalent fractions plus 4 more, right? Plus 4 hundredths. So over here, I actually have 34 hundredths. I actually have 34 hundredths. Now let's take a look over here. And you can see that I have 6 tenths shaded in. But if you count all the little tiny cubes, I actually have an equivalent fraction, which is 60 hundredths, right? Because I can take 6 over 10, multiply times 10 and times 10, right? In fact, I'll just do that for you right here. Remember this, and we end up with 60 over 100, right? Same thing if I took 3 tenths and multiplied by 10, I get 30 over 100 plus 4 over 100 is 34 over 100, right? So now it becomes very, very clear that 34 hundredths is less than 6 tenths. And again, the most common mistake many students make is they look at this and go, oh, there's more digits, so 34 must be greater than 6. But in reality, what you're actually looking at is 6 tenths and no hundredths. So you can annex that 0 right there without changing the value of this. And now 34 hundredths is less than 60 hundredths. All right, let's look at this. Let's look at this one more way. We're going to create a number line right down here. And we're going to start at the 0, and we're going to go all the way up here to the number 1. Okay, and I'm going to cut this in half right here, and this is going to be 0.5, right? So now we're going to mark it off. 1, 2, 3, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, okay? And then 10 tenths equals 100, right? So we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and when we get to 0, when we add one more tenth to it, you carry the 1 over here and you get 1 whole. So now let's place these on that number line, okay? So we have 0.6. Well, that is going to be right here on the number line, right? That's 0.6. That's already there. That's super easy to spot. Okay, so 0.6 is right there. There is 6 tenths. Okay, now we have to compare it to 0.34. Well, we have 3 tenths and 4 hundredths. So what we have to do is split this into 10 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't fit them all in there. 10. They're so tiny, right? And now I have 0.34. So I've got 0.3, 3 tenths and 4 hundredths. 1, 2, 3, 4. It looks like it's right about there. Hopefully you can see that. And I've got 0.34 right there. So then again, on this number line, it becomes very, very obvious that 0.34 is less than 0.60. So don't get fooled by the fact that it started out with more digits. It's just that this 4 is incredibly small. Look at how small these hundredths are. as you mark them in there, right? So the 3/10 is here and then add 4/100, whereas the 6/10 is here and it is actually 60/100. So hopefully that helps your understanding. One more way you can think about it, it's always good to relate decimals to money, and 0.34 is equivalent to 34 cents. So you can also think of it that way, right? 34 cents, right? So you could do a quarter and 9 pennies, right? Something like that. And 0.60 is equivalent to 60 cents, right? So, oops, hang on. So let's go with that. Okay, it's equivalent to 60 cents. So 0.60 if you were thinking about it in terms of money. So here we have no dollars, 3 dimes, 4 pennies, no dollars, 6 dimes, no pennies. So this one, again, clearly the bigger decimal. Thanks. I hope you enjoyed this lesson and I hope you keep practicing. Remember, math is everywhere. Bye.